All right. So what I did was I took the sample program, which was in the laboratory assignment, and I pasted it into the Arduino IDE. If you look at the code, we can run through it just real quick. There's a CBI macro. What this does is it'll take a register, any register, and set an arbitrary bit in that register. So if you go in over here, you put in a data direction register, and you put in 0 over here, that'll clear bit 0. You do SPI data direction register 0, that'll set bit 0. So that's the only thing that this does. If you go to the constants in the program, which are right at the top, let's consider this very fine program. Constants are at the top, so I've declared the DAC right prototype, which is up here at the bottom. I got my constants over in here. That's the number n for the number of samples in my wave table. Delta theta is the actual increment that you're going to have in radians for the sine wave. And the sine table is already declared and allocated as unsigned 16-bit quantities. And then the rest is variables, which I'm going to use later in the program. This is boilerplate for setting up the SPI interface. And then the only thing you got to do is take a look at the loop. And the loop is done without any interrupts at all. All I do is I get an index, I go up by some dx, which is going to be adjusted by my analog read, and I'm going to check to make sure the index doesn't exceed the sine table length. If it does, I've got to set it to 0. And then I take that value and I write it out to the DAC. So the sine table is all pre-computed. Nobody's going to do any trig functions live, because Arduino is too slow for that. So we're trading off space for time, allocating the time up front, because it's pay now or pay later, and some space in the sine table to do all of the trig functions. So all I have to do is read from the sine table. Then I read my little diddle pot, the analog read. I get a value, divide by 32, and that becomes my dx. And I use that to change my increment through the sine table in this loop. The DAC writes out 16 bits because I got a 12-bit DAC. 12-bit DAC means I can go from 0 to 4096. That's 2 to the 12. So what I do when I create my sine wave is I take sine, which is equal to a number that goes from -1 to +1. I offset it by 1. That makes it go from 0 to +2. Multiply by 2040. That means 2 times 2040 is 4080, which is a little bit less than 4096. So I get a little headroom. And then I put that into my sine table. My delta theta, I pre-computed it as 2 times pi divided by n, where n is the number of elements in the sine table. And all I need to do is loop through one pass and set up my sine table in advance, and I do that in my setup. That's just how I do the setup. You're going to take that setup, which I've got in here, and I'm going to comment out the if-else statement right now, and that's going to turn this into a nice pure sine wave. Then I upload it to my little audio shield and crank my speakers a little bit. Now, using the program from the Microsoft App Store called SoundScope for Windows, now you can see it's not locked. If I set the auto trigger to on, it locks. which will let you do the oscilloscope. So, not to put too fine a point on it, I took my, I found in the App Store something called Oscope, and they give you a nice Oscope. You can take a picture of that as well and do your homework that way instead of using Windows. Or you could, maybe your Mac could run some software. I think I demoed that in my video, which is in the lab. So there's a couple of sample labs for you guys to watch. And so that's a couple of ways to get the oscope. The third way to get the oscope, the fourth way, I guess, you could use a real oscope. And what we did was we had an audio cable which could plug into your sound shield, and that will let you drive the oscope directly, and you can take a picture, and square waves will be really square. Sine waves will be really, really soft.
You only need that if you want to put it on the actual scope.
Yeah, I'm wondering if that scope doesn't have some way of helping us. Because I see a USB.
Oh, so if you, and not directly to a computer, you have to actually plug a USB drive into it, which is dumb. But if you plug a USB drive into it and click save, it'll save that picture, and then a file, an Excel file will follow up. Well, it's CSV.
That's nice. That's nice.
Yeah, so I have an analog one at home. So yeah, I've you know, old Tectonics analog one. So when I come in here, I'm like, whoa, you can do that.
That's nice. Yeah, I have one that mounts a Polaroid.
Yeah, I like sit there and I'm like writing down my peak values and like counting boxes, you know.
So, any questions? So let me put the code back up so you can see it. That's the shtick. You're basically building a function generator with software and a little bit of hardware. Let's see if there's any participants here in my. No, there's no participants. I think I'll stop the recording.